Hello to all my advanced topic students out there, and welcome to week 2 of online instruction. All right, I hope everybody's doing well out there and staying safe and healthy with their families. I miss seeing you guys in the classroom. Hopefully we'll get to see each other again soon. In the meantime, I just wanted to touch base with you before we get started with today's lesson, talk to you a little bit about what's going on and what's coming up. All right, so this week we're going to continue our discussion on probability. This is a pretty long section. It'll take us a couple weeks to get through. I'll probably throw in a mid-chapter quiz like I have been in the past, probably at some point next week. I'll talk to you a little bit about that a little bit later on this week about how that's going to work. All right. Make sure you're keeping up on your Khan Academy assignments for the week. I still got a handful of people out there that are not turning in daily assignments and keeping up on the bell work. Please make sure that you're keeping up on that. Don't fall behind. I am posting grades pretty much daily in Google Classroom, and then of course weekly in Focus. So keep up on that. I'm trying to post everything in Focus and in Google Classroom, so that way you and your family can keep up on what's going on from one day to the next. Big shout out to 6th period. All right, great job guys. 29 out of the 32 students in that class scored a perfect score on both assignments for Khan Academy last week, and all 32 at least attempted the assignment. So no zeros on Khan Academy for 6th period. Great job guys, I appreciate it. If you need anything, email me, comment on the post, comment on the videos on YouTube, whatever you need to do to contact me. Let me know how I'm doing. Let me know what I can do better to help you guys learn. All right, so that being said, let's go and get started with today's lesson. All right, so yesterday I posted a video that I thought did a pretty good job of explaining theoretical probability. So today I wanted to post some examples of different types of problems that you might run into based on those concepts. All right, so let's take a look at a pretty simple example. All right, yesterday in the video I talked about marbles in a bag. Today I've got colored cubes here. All right, so I've got 4 yellow cubes, 3 red cubes, and 2 blue cubes. All right, so let's say that I put these into a cup and I shook them up, and then I reach in there and I want to randomly grab one out. So I want to figure out what's the probability that I end up picking out a certain cube. All right, so let's start off easy. All right, so let's say I want to find the probability, if I randomly choose one of these, that I pick a red cube. Okay, so how do I write that? Well, I'm going to use capital P to represent probability. Okay, and then next to that in parentheses, I'm going to put what I want my favorable outcome to be. Remember, favorable outcome is what I want to happen. All right, and that is that I want to pick a red cube. Okay, so I'm saying what's the probability of getting a red one? All right, so probability again is total favorable outcome. So how many different ways can it happen, divided by total outcomes, how many different possibilities are there if I pull one cube out? Like how many different things can happen? Okay, so favorable outcomes is how many ways can I get a red one? Well, there's 3 red ones out of the bunch. So if I pick one cube, all right, 3 of those, all right, could be red. So 3 is going to be my favorable outcome because there's 3 ways that I can choose a red one. I can choose that one, or that one. Total outcomes is how many cubes do I have to choose from? All right, so I've got 4 and 3 is 7, plus 2 is 9. So I've got a total of 9 cubes to choose from. So that is my total outcomes, okay, or my sample space, all right, what I'm choosing from. All right, so probability of getting a red one, there's 3 red out of a total of 9 possible cubes. Always simplify your ratio. So 3 over 9 simplifies to 1 over 3. So the probability of choosing a red cube is going to be 1 over 3, or 1/3. Okay. Now, I can also do the complement. All right, so that should have been in the notes if you didn't already take a look at that. Now, the complement means that I want to pick something that's not going to happen. Okay, so let's say that I want to find the probability of picking one cube out of there and it not being red. Okay, so I want to do not red. All right, so remember, to find the complement, I'm going to take how many ways that can happen and then I'm gonna subtract it from the total, which again is 1. All right, so we figured out the total probability for finding a red one. That was 1/3. So to find the probability of not picking a red, it's going to be 1 minus 1/3, or it should be 2/3. Okay, and then we can confirm that just to be sure, because our favorable outcomes, all right, all the ones that I pick, all the ways that I can pick one that's not red are either yellow or blue. So 4 and 2, that's 6 possibilities of me picking a cube that's not red. And then there's a total of 9 cubes still in there. So again, that simplifies to 2/3. All right, so let's take a look at a couple examples using a number cube. All right, so it has 6 sides, all right, numbered 1 through 6 on it. All right, so we want to take a look at some probabilities that if we roll that cube, which number will come up, okay, or based on what scenario. So let's start off with something simple, all right? So there's 6 sides, all right? We learned in the video that obviously they're all equally likely of coming up, so whichever number comes up has a 1 in 6 chance to come up, all right? But what if we have more than one option when we roll that cube? So let's say we want to find the probability of, if we roll it, we get an even number. Okay, so probability of rolling an even number. Well, there's 6 numbers, 1 through 6. All right, so total possible outcomes is still 6. All right, but then how many ways can we roll an even number? All right, well, we can roll a 2, we can roll a 4, or we can roll a 6. All right, so those are all even numbers. So there's 3 possibilities possible ways that can happen. So my favorable outcomes would be 3. Okay, so 3 over 6, so of course that simplifies to 1/2. So there's about a 50% chance that if I roll it, it will come up an even number. Okay, so equally likely, because there's the same amount of even that there are odd, those two are known as equally likely. All right, the same chance, 50-50 shot of them coming up. Okay. Something else that we can look at, let's say that if we wanted to find the probability of rolling a number less than or equal to 4. Okay, so a 4 or less. Okay, so I want to do less than or equal to 4. Okay, so what's the probability of rolling a 4 or less? All right, so if I take a look at the total possibilities, all right, so how many numbers are equal to 4 or less? Well, there's 4, then there's 3, then there's 2, then there's 1. So there's 4 possibilities that can happen there. So that would be 4, and then still have a total outcomes of 6. So 4 over 6 simplifies to 2 over 3. So there's a 2/3 chance of me rolling the die, or rolling the number cube, to get either a 4 or less. All right, let's take a look at one last example. All right, so here we have a deck of playing cards. Hopefully at some point in your life you've seen them. All right, so let's say we want to play a friendly game of solitaire, and we want to find the probability of a particular card being drawn out of the deck. All right, so if you don't already know, all right, there are 13 cards of 4 kinds of suits, is what they call them. They have hearts, diamonds, clubs, and spades. All right, it's 13 of each. All right, so a total of 52 cards in a standard deck. All right, and then these are the actual cards. There's an ace, and then there's numbered cards 2 through 10, and then there's a jack, a queen, and a king. Those are known as face cards. Okay, so a total of 52 cards there. All right, so all 52 cards are unique based on their value and which suit they're in. Okay, so there's one of these cards in each one of these suits. Okay, so there's 4 aces, there's 4 2s, there's 4 3s, and so on. All right, so we want to take a look at the probability of what happens if I take this deck and I shuffle it, so that way the cards are mixed up in random order. All right, and I want to find out what's the probability if I pick a random card that I choose a particular one or a particular type. All right, so let's start off with something easy. Let's say that if I pick a random card from in the middle of the deck or off the top of the deck, that it is a heart. Okay, so there's 13 hearts, so I want the probability of picking a heart. Okay, 13 ways that can happen, because there's 13 heart cards in there out of a total of 52 possible outcomes. All right, so then if I simplify that, then that means that there is a 1 in 4 chance, or approximately a 25% chance of choosing a heart out of that deck. Okay, pretty basic example there. Let's say that I wanted the probability of picking an ace. Okay, so probability of picking an ace out of the deck. All right, well, how many aces are there in that deck? Well, there's 1 ace of each suit, so there's a total of 4 aces, so that's my favorable outcomes. And then there's still 52 cards in the deck, so it's going to be 4 over 52. And then I simplify that, it becomes 1 over 13. So I have a 1 out of 13 chance of drawing a random card and it being an ace. All right. How about, let's say if I want the probability of choosing a face card. Okay, so remember, a face card are your jack, queen, and king. There's 1 of each card in all the suits. All right, so that means that there's a jack of hearts, a diamonds, a clubs, and spades, and then there's also a queen and king of all 4 of those. So there's 4 jacks, 4 queens, and 4 kings. All right, so the total face cards in the deck is going to be 3 times the 4 suits, so 12 favorable outcomes, still 52 cards in the deck, and then I want to simplify that, and that reduces to 3 over 13. Okay, so there's 3 possible ways out of 13. This probability of choosing a face card. All right, let's say that I want to say, what's the probability of choosing a number card? Okay, so last one we'll do probability of choosing a number card. Okay, so I want to say, okay, how many are in there? So there's a 2, a 3, a 4, a 5, 6, all the way through 10s. All right, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities. All right, out of each suit, and then again, there's the same in each suit. So 9 times 4 is 36. So there's 36 number cards in the entire deck out of a possible 52. And then I simplify that, and that becomes 9 out of 13. Okay, so a lot of different options that you can do when estimating probability. We'll do some more examples on that, maybe some more complicated on that one when we start doing compound events in another section. All right, so hopefully that helps. Tomorrow I'll have a worksheet assigned for you to do some practice problems, and then the rest of the weekend you'll be off, and I'll post the solutions on Monday. All right, have a great day.